Hello everyone, welcome back to Piece of Physics. In this particular video, we are going to start our new topic, which is projectile motion. In earlier videos, the questions and theories which we dealt with was all about motion in a straight line and motion in a one dimension. Okay, so from this particular topic, we are going to start motion in a plane. Basically, in first kind of motion in a plane is projectile motion, and second type of motion in D but 2D is circular motion. Okay, so here this is y-axis, this is x-axis. Okay, and we are throwing one object from origin to like this. Okay, with projection angle of theta with respect to positive x-axis, right? And the gravitational acceleration on this particular object is basically downward, right? So here the initial velocity of object is taken to be in this particular direction, v naught. Okay, and two components of this particular velocity will be v naught cos theta, which is in this particular direction, and another component of velocity will be in this particular direction, which is v naught sin theta. Okay, here air resistance is negligible, and also remember one thing: acceleration is only in the y direction, which is below, which is towards the earth. Basically, the object will be dragged downward due to gravity, and acceleration in the x direction basically taken to be zero. So means the x component of velocity will remain unchanged during the projectile motion. Okay, so what happens here is I can make velocity vector like this. X component will remain same, but y component will decrease. At the maximum height, there will be only x component. Then x component will be like this, and y component will be downward because object is now moving in the down vertically downward direction. And here y component, x component will be in this direction, component will be this direction. Okay, so that's how we can also demonstrate velocity vector during the whole projectile motion path. And also remember one thing: at the maximum height, the only velocity which will be there will be only v naught cos theta. Okay, so at the maximum height, there will be only v naught cos theta. Now let us have two parameters. Now let us make one table like this. This is horizontal. This is vertical, right? So initially, this is x direction. This is y direction. First, we are going to have initial velocities x component. This is ux, which is v naught cos theta, and the initial velocities y vector will be v naught sin theta. Acceleration in the x direction is zero. Acceleration in the y direction is okay. Now x component of velocity will change like this: vx equals to ux plus axt, and we can write vx equals to ux is basically v naught cos theta. Ax is basically zero, so second term of the velocity will be zero. Okay, and this is vy equals to uy. So vy to uy a by t. Okay, so I can write it as vy equals to v naught sin theta s gt. Okay, now you can take this equation as equation number 1 or 2. Apart from this, we should have two coordinates. One is x coordinate, second is y coordinate of the object during the path of the projectile. So x coordinate is uxt plus half axt square. Okay, so x is ux is v naught cos theta into t, and kx is basically 0, so second term will be 0 vy, and y coordinate will be uit plus half ayt square, and y component will be this is v naught sin theta t minus half gt square. Okay, you can take this equation as equation number 3 and this equation as equation number 4. So here we are having four equations. One is here, second is here, third is here, fourth is here. Okay, so these are the four equations which we are going to use to derive different kind of parameters. First parameter is going to be time of flight. Second parameter will be range. Range is basically this particular distance. This is our range. Third parameter will be maximum height reached here. Fourth parameter will be our equation of path of projectile. It means that how object is traveling in two dimension. Okay, so now let us find these particular parameters one by one. So our first parameter is time of flight. Okay, so how we are going to find this equation? So how we are going to find this parameter is like, okay, so the maximum height object is at rest. It means y component of velocity is 0. Okay, so now we can use our equation like this. Vy was ui plus ayt. Okay, so basically Vy equals to, I can write 2 sine theta minus gt. Okay, so basically this will give us the half time to reach the maximum height, and another time will be time for descent, which will be our second time. Okay, so here the velocity is 0, so I can write 0 equals to u sine theta minus gt. So t will be u sine theta divided by g. Basically this is the time for ascent. Okay, and time for descent will be u sine theta divided by g. This is time for descent, right? So total time for the time of flight will be equals to 2u sine theta on g. Okay, so our time of flight is basically 2u sine theta by g. So that's all for this particular video. In the next video we are going to derive equation of horizontal range. Thank you so much.